Hello, my name is David Herman. I'm from an air pollution health effects lab, and today I'm going to talk to you about how particle matter enters your body and causes blockages. Emphysema and Alzheimer's, two completely different and devastating diseases. Or are they? It turns out that both are linked to increases in air pollution, which is a mixture of gases and what we refer to as particulate matter. You could think of this particulate matter as tiny pieces in the air that decrease visibility when it's highly polluted. Worldwide, by 2050, it's expected that the number of premature deaths as a result of exposure to this particle matter is expected to skyrocket to 3.6 million worldwide by 2050. To help us visualize these particles, we could think of them as tiny chocolate-covered raisins. The outer chocolatey layer is composed of organic materials, metals, and other toxicants, while the inner layer is composed mainly of elemental carbon and other refractory materials. These particles get into your body when we breathe. This leads to lung illness such as asthma, chronic obstructive pulmonary disorder, emphysema, and bronchitis. The smallest of these small particles can actually get into your brain, where they lead to neurodegenerative disorders such as Alzheimer's and Parkinson's disease. There are many ways to study this particulate matter. One of the ways is to generate your own. I've shown a couple of methods here, but what you could do is generate particle matter with a known concentration, size, and dose, and figure out how that interacts with your body. So if you know what compositions or size or materials are within these man-made atmospheres, you could figure out how they interact with your body. That's a problem though, because air pollution has many particle types, many gases. So to get around this, what we do at our lab is pull in local air from just above the surrounding roof lines. This way we can capture all the particle matter that we breathe in every day on a daily basis. However, blockages take a long time to form in your arteries. So in order to make this particulate matter experimentally relevant, we have to concentrate it. So what happens is the particles go through a series of saturators, chillers, condensers, and dryers, and on the other side of it, they end up being 10 to 20 times their original concentration and ready to be used as exposure atmospheres. What I'm interested in is the chocolatey organic layer of these particles. So pretty much using heat, we can melt off or vaporize the more organic volatile of these compounds and capture that in a semi-volatile organic cloud. We can then take that cloud and expose it to mice. But because we're capturing a local environment, we have to know what's in that environment. So using a plethora of techniques, we can figure out the concentration of the particles, whether there's metals attached to them, what mass they're at, and what the semi-volatile layer is composed of. And once we know all that, we deliver it to mice. These mice are exposed on and off for about 2 months. That's about 20 years for us humans, so exponentially longer. And at the end of the 2 months, we can collect the arteries of these mice and figure out how much plaque formation has occurred. The way I'm going to go about this is to look at genetic markers in the arteries that normally accumulate the plaques. The few genes I'm looking at are called adhesion molecules. They are involved with how the plaques start to form within the arteries and infiltrate the arterial walls and form more plaques. Because mice are so small, their arteries are even smaller, dare I say tiny. So because of this, we have to use a laser to dissect out the plaque formation and the genes within that and isolate those genes, and then we can do a series of analyses to figure out what genes are there, if they are adhesion molecules, and at what concentration they are there. Now, these plaques form at specific sites within the arterial wall, which is good for us because it allows us to look at a single mice at areas with and without the plaque and use that mice as its own control. So that specificity really comes into play here. Now, these plaques, they form in more places than just your arteries. It's been shown now that since the smallest of these small particles can actually get into your brain, plaques have been shown to be a key role in the way that these neurological diseases play out, such as Parkinson's and Alzheimer's. They involve the buildup of plaques in your brain. So it'd be good if we can find out the genetic markers for the early progression of these plaques and maybe find out if they are the same within the brains and find out a way to identify these plaques before they start to build and build and build and cause actual neurodegenerative and arterial problems. One way to do it is through industrial size heaters and filters. What you could do is send all of the emissions of an industry through a heater, and it will heat the particle matter, stripping off the semi-volatile particles. Then you can collect those particles with materials like charcoals or ceramics along with the interior part of the particle matter. And that way it gets collected before it gets released into the air where you and I can breathe it on a daily basis. These things are expensive, it takes a lot of regulatory involvement. Some of it is being done, but it's a costly endeavor. As we can see, microscopic particulate matter makes up a large part of outdoor air pollution and plays enormous health implications. Using methods we have today at a relatively low cost, can we stem the development of these plaques and limit the amount of neurodegenerative diseases we see in the future? It might be the answer to this very, very large problem comes in something very, very small. Thank you.